Okay, in this video, we're going to look a little bit at compound interest. So this is something you should have done in some algebra class at some point, but we will need it a few times this semester. So we're just refreshing it and also using this as an opportunity to just talk a little bit about some kinds of functions that we might need to remember. All right, so we've got some information here about an amount of money invested for a certain time interval with a certain interest rate and different kinds of compounding. So hopefully not too far back in your memory is a formula for that. I'm going to write two formulas down over here, and then we'll talk about which one is for which kind of problem. So one of them, you might have used different letters when you looked at this before, but these are the letters our textbook uses. A equals P times 1 plus R over N to the NT power. So this is the formula for compound interest, everything except continuously. So the idea here is that the A is the amount of money in the account. The P stands for principal, or that's the amount of money invested. The R is the interest rate as a percentage, but written as a decimal. The N is the number of times per time unit. In this case, our time unit is years. So the N is the number of times that the interest is compounded. In this case, per year. It could be per month or whatever, but in this case, our time unit is years, so I'm just going to write year here. And then T is the number of years. All right, so this is the basic formula again, hopefully not too far gone in your memory, but if it was, then there it is, write it down. All right, so we're going to use that for the first three parts here, and then we'll have a different formula for the last part here when interest is compounded continuously. So the idea with continuously compounded interest is that you let the N approach infinity or grow larger and larger and larger until it becomes infinitely large. And so we will look a little bit more at things where we have a variable approaching infinity and talk some more about that this semester. But for right now, I'm just going to go ahead and write down the formula that we're going to use for continuously compounded interest. I'll go ahead and put that over here. A equals P times E to the RT. And P is the principal, the amount invested at the beginning. R is the interest rate, written as a decimal. T is the number of years. And E is the transcendental number E, sort of like pi. You're on your calculator, so 2.7-ish. And your calculator will calculate that for you. So we'll do some more with E as we go through the semester to hopefully refresh your memory with that. All right, so in this video, we're just going to do these calculations, and I'm going to let my calculator do the work for me. So I'm going to write down what I would have typed into my calculator and just write down the answer. We'll look at another video where we do a couple more calculations with some of these values and do a little bit more in-depth problems. All right, so annually, that's once per year. So this would be when our N is equal to 1. And so we're just going to put into the formula here our amount is going to be the principal, the $10,000, times 1 plus the R, the interest rate. So 5%. Remember to change a percent to a decimal. Its percent is out of 100, so this is 5 out of 100, so 0.05. And then once per year. Annually is once per year. So I don't really have to put dividing by 1, but I'm going to go ahead and put it there just so you can see the patterns. And then to the power of 1 times 3, which is obviously just 3. So you don't have to write 1 times 3 up there. If you type this into your calculator, you will want to put parentheses up here, and depending on the calculator model you have. But you want to make sure that the calculator does, if you have a number here that's not 1, that number times the 3. So in these others where I have other numbers here. All right, so I went ahead and typed them into my calculator already so that I wouldn't have to stand here and do that. And for this first one, I got $11,576.25 exactly. Okay, so just thinking about what's happening with these others. So if I have this certain interest rate and I compound it more often per year, they're adding in the interest more often per year, I should end up with more money. So they take that interest rate and divide it up 4 times per year, then the money that's added in earns its own interest. So all these other answers should be a little bit bigger than $11,576.25. All right, so you should probably try on your calculator as well to make sure that you can type it in correctly and get the answers that I'm getting here. But for quarterly, that would be 4 times per year. So n is equal to 4. So I'm going to have 1 plus 0.05 divided by 4. And then to the power of 4 times 3, or 12, if you just want to write that as 12, I'm going to write 4 times 3 here. And then when you type that into your calculator, maybe pause the video, type it in, and then check to see if you get the same answer that I got. Okay, so if you did that, you should have gotten $11,607, and then 0.54518. If we're talking about money here, I'm going to round to cents, and I'm going to put the squiggly equals to indicate that I've rounded here. So rounded to 2 digits after the decimal, it would be 0.55. Okay, and then monthly, that would be 12 times per year, 12 months in a year. So A is $10,000 times 1 plus 0.05 divided by 12 to the power of 12 times 3, or you could just type 36 into your calculator, and this should be a little bit more. So let's see, I got $11,614 and 0.72231. So rounding to cents, 72 cents. All right, and then the last one here for continuously compounded interest. Again, that's using this E that's on your calculator. So you're going to type in, you're going to find that E key on your calculator. It's in 2 different places. On my calculator, it's a second, and then it's above the ln key. So 10,000, and then E to the, and then I'm going to have my rate is 5%, so 0.05 times 3, or 0.15 if you want. So 10,000 times E to the 0.15 power. And that should be a little bit more. So $11,618 and 0.34243. So again, since we're talking about money here, we'll round to 2 digits after, so 0.34. All right, we're going to look at another video and do a little bit more with this continuously compounded interest. I could do similar problems with the compounded annually, monthly, or quarterly, but I found that a lot of students need a little bit more refresher about the E and how to work with the E. So we're going to do another video and look a little bit more at that continuously compounded interest and answer some other questions about what might happen with this investment if I leave it in for longer terms, or if I want to reach a certain goal with my investment.